The 2004 past paper question. Pressure. This is volume axis. And we have given a diagram. You had a tute, right?
Yes, teacher.
So last class we studied an equation W is equivalent to P into delta V. Work done by gas is given by P into delta V. Yeah, P is the pressure and delta V we told as change in volume. Okay. Now you know in mechanics and all, if you have a velocity time graph, let's say this is the graph. Area under the graph gives what? Displacement. So how did it give? We know velocity is equal to displacement divided by time. So displacement is equal to what? Velocity into time. The product of the y and the x-axis gives the area. Similarly, this is P, this is V. So P into V gives work. That means area under the PV graph, what does it gives means it is giving the work done. So that is the question. The 2004 question is work done during the cyclic thermodynamic process ABCA indicated in the PV diagram. So work done during the cyclic process ABCA they are asking. Now, first of all, the gas is moving from A to B. That is one process. A to B is one process. Second process, B to C. B to C is another process. Then finally, C to A. But they are asking the total work done. The thing is now we can find the individual work done and then find the total work done or directly we can. Now you see, first let's find it individual. Okay. Now when I consider A to B process, okay, A to B process when I consider gas is moving from A to B. See, its volume increases. Initially its volume is V. Now its volume is 3V. Now work is what? Work is pressure into change in volume. Always change means final minus initial. That we consider is as change. Now, in the process A to B, if you consider A to B process, work done is pressure into change in volume is V and 3. Volume is increasing. That means work is positive. So A to B, work is positive. How we find work is positive? Because when we are going from A to B, its volume is increased. So work done in the process AB is given by area under the graph. Similar to this. Okay? This is a PV graph. PV graph, area under the graph gives work done. Now the question is work done during the net process. But now for studying and everything, first of all, individually I am finding AB process. Considering only AB process, work done is given by this AB, this graph under the graph bounded with the x-axis. So this is a trapezium now. Therefore, its area is half into sum of the parallel sides. This is 4P. This is P. Then 4P plus P into distance between these two is 2V. Therefore, 2 get cancelled off. So 5PV is the work done during the process A. Then for the next process, B to C. First it is moving from A to B. Then it is moving from B to C. No. Then for the process B to C, work done I can find. Now you see, when it is moving from B to C, initially its volume is 3V. Now its volume is V. Then what is happening? Volume is decreasing. Now work is pressure into change in volume. Therefore, work done is minus in this case. In the process B to C, work done is minus. Okay? Because always that day I told you, we are using the equation delta Q is equal to delta U plus delta W. So the delta W, when will be delta W plus is work done by the gas. If the gas does work, delta W is positive. When it will be minus, work done on the gas. If we do work on the gas, it will be minus. Okay?
Yeah.
So, now work done by the gas is plus. That means you can check using this equation also. Now A to B process volume increases. So work is plus, it is done by the gas. Now B to C process volume decreases. So work done will be minus. So that means work done by the gas. In A to B process, B to C process, we are doing work on the gas. Okay. Therefore, what we consider as positive means work done by the gas we consider as positive. That means work done on the gas will be negative.
Negative.
Then B to C process. When I consider B to C process, work done will be given by area under the graph. Therefore, that is what it's like a rectangular portion. The pressure is P, change in volume is 2V. Therefore, P into 2V. But if they ask a question like work done by the gas, it will be minus because really work is not doing by the gas. We are doing work because its volume is decreasing. So minus P into 2. Then when you consider C to A process, work done by the gas is 0. Why? Because initial position C also its volume is V. Then it is reaching position A. No, in position A also its volume is V. Therefore, work is equal to what? Pressure in change in volume. Therefore, change in volume is 0. Therefore, C to A process, work done is 0. Now, in exam, the question they ask is, work done during the cyclic thermodynamic process ABC indicated in the PV diagram is the question. So one means we can find individually A to B process we can consider first. Then we can consider B to C process. Then C to A process. Now C to A process work done is 0. A to B process 5 PV. Here B to C process minus 2 PV. Therefore resultant work done is 3 PV. Therefore we can go to answer third. But there is another way easily we can think because it is difficult write each and every process. No, neatly we can consider. Now they are asking for the total process. What is the net work done? Okay. Then we can calculate it easily. How to calculate it easily is now let's say what is the process happening is gas is going from A to B, then from B to C, then from C to A. So A to B process work done is given by area under this graph. Okay. Then B to C process. B to C process means what? B to C process work done is given by area under this graph. Okay. Then C to A process is what? Net work done is 0. But A to B process work done is given by area under this graph. B to C process work done is given by area under this graph. Therefore, net work done is given by area inside a triangle, which is half into base is 2B into perpendicular height is 3P. Then we can write directly 3PV. So what I am telling is now individually we calculated A to B process, what is the work done? Then B to C process, what is the work done? Then C to A process, what is the work done? Without doing individually, we can directly come to this answer. What is the ways if for any process, okay? For any process, the resultant work done is given by the area inside the shape like that. Shortly, we can put to conclusion because now you see the A to B process work done is given by this black color, this line. B to C process, this solid line. Therefore, they are asking C to A process 0, no, net work done. No. Now you see A to B process work done is plus. So this totally plus. Then B to C process minus. So this common area is deducted. The net area is given by the area inside ABC, which is half into base is 2P into perpendicular height is 3P. Therefore, 3PV. Did you get it?
Yes, teacher. So if for the next time, if we take for the area of that object, it would be enough, no? To take it there quickly.
Yes, area inside that shape. Any shape, it doesn't matter. Area inside it. We will do some more questions, then you will be clear. Okay, right there.
I have another small doubt. Now, in the question, they have told work done during the cyclic thermodynamic process ABC, you know. So how do we know whether they are asking work done by the gas or work done by us to the gas in the question?
Normally, they ask work done by the gas. You see work done during the cyclic thermodynamic process, because every answer is positive now. So if they give plus and minus sign, they will specify. Now you see below question, ninth question, you see they have given some plus answers and minus answers. They have specifically asked work done by the gas during one cycle. Can you see that
Yeah.
question?
Yeah, it is.
Yes. So here everything is positive, therefore they didn't specify. Normally they are asking work done by the gas only. That's why it is coming plus. Otherwise,
Okay.
if it's work done by the gas is 5 PV, work done on the gas is minus 2 PV. If they ask work done on the gas, it will come minus 3 PV. Other way around, so no minus answers, right? So therefore,
Yeah.
we got to come to a conclusion work done by the gas.
Okay.
Okay, write this.
Done, teacher.
We'll look at the next question. Question number 8, 2005 question. Question 5. Question number 8. So they are given a P versus V diagram. So volume is measured in meter cube. Pressure is measured in Newton per meter minus 2. And they have given a graph. A, B, C. This is 1. This is 3. This is 1. This is 4. So what is the question is, figure shows a PV diagram of a perfect gas subjected to a cyclic process ABCA. In this process, we are talking about heat. Now, heat means what? Delta Q is equivalent to delta U plus delta W. They are talking. And using this graph, what is the data? We can find this delta W. Then we have to substitute in this equation in order to find delta Q. Okay. Then work done, we know it will be given. Net work done is area inside this shape. Therefore, delta W we can write. Delta W is equal to half into base is here 1, 3. This is 2. Base is 2 into perpendicular height is 3. Therefore, we can write 3 joules is the work done. So that is a shortcut way you can write. Or otherwise, each and every process similar to what we considered in the previous question, we can consider. A to B process, work done is given by area under this. A to B process. Then B to C process, net work done is given by this. Therefore, net work done is given by what? Area inside this. Because C to A work done is 0. Same question. Or else, according to now we know area inside the shape gives a net work done. Therefore, directly we can write half into base is 2 into perpendicular height is 3, therefore 3 joules. Okay. Now we know work is 3 joules. Now if this work is plus or minus, now we can consider. Now see, now A to B, work done is given by area under this graph. B to C, this small portion. Therefore A to B only major portion it is contributing. Now A to B, what is happening? Volume is increased. Therefore, work is equal to P into delta V. If volume increases, work is plus, which is work done by the gas. Therefore, this is plus 3 joules. Okay. Next one, we have to calculate the internal energy change. Then only we can calculate delta Q. Okay. Now, for a cyclic process, delta U is 0. I'll tell how it is. Now, first of all, internal energy. Now, what is this internal energy? Is this. Now, normally, when you consider internal energy, there are 2 types of energies. Okay. Internal energy, energy of a gas. Internal energy of a gas molecules, there are 2 types. One we call as kinetic energy and another one we call as potential energy. One is kinetic energy, another one is potential energy. Now, in our syllabus, we are talking about ideal gas. Here they are mentioned as perfect gas. Question number 8, figure shows a PV diagram of a perfect gas. And
Teacher, I can't hear you properly.
gas.
Your sound is stucking. Teacher?
Hello?
Hello, teacher, can you hear me? Teacher?
I can hear. Yes. Hello?
Teacher, now I can hear you.
Yeah, clear.
Yeah, it was not clear, teacher. Now okay, teacher.
Okay. So what I'm saying is internal two types of internal energies. One is kinetic. We have mentioned the word is perfect gas. Perfect gas or ideal gas. So you know, for ideal gas molecules, attraction is nil. Therefore, what we can say is potential energy of ideal gas molecules is nearly equal to zero. Therefore, its energy only depends on what? Kinetic energy. Okay, in chemistry, you would have done in the fourth lesson. Ideal gas molecule attraction force is energy. For ideal gas molecules, potential energy is zero. Therefore, its internal energy depends on kinetic energy. Okay. Then, kinetic is a relationship you studied in chemistry also you would have done. The kinetic energy is directly proportional to absolute temperature. Kinetic energy is directly proportional to absolute temperature. Absolute temperature means temperature is measured in Kelvin. Okay. Now, internal energy. This internal energy depends only on kinetic energy. Okay. Internal energy depends only on kinetic energy. But we know kinetic energy is directly proportional to what? Absolute temperature. So, combining these two, we can write internal energy is directly proportional to absolute temperature. Internal energy is directly proportional to absolute temperature. Okay. Now, when you consider this, the gas initially it is starting from A and it is coming back to A. First, A to B process is happening. Then B to C process is happening. Then C to A process is happening. Now, again, it is coming back to A. Okay. Now, we have to calculate the internal energy change. Now, initial position is also A. Final position is also A. Then internal energy change is what? Now, internal energy is directly proportional to absolute temperature. So, we know in chemistry, there is we have an equation, ideal gas equation. PV is equivalent to NR. Okay. So, R is always a constant. Why? Universal gas constant. It won't change. Then, this is for a gas. Now, you see the question. Figure shows a PV diagram of a perfect gas. For a particular gas, we are talking. Since we are talking for a particular gas, its number of moles won't change. Therefore, this PV product is directly proportional to temperature. But we know temperature is directly proportional to what? Internal energy. Therefore, initially it is at A. Then it is the gas is going from A to B, then B to C, then C to A. Again, it is coming back to A. Therefore, temperature change is zero at this position. Same PV product. That means initially also its internal energy is U. Now also its internal energy is U. Therefore, change in internal energy delta U is U minus U, which is zero. Therefore, easily we can come to a conclusion. For a cyclic process, internal energy change is zero. Cyclic process means if it starts at A, again it is coming back to A. Directly we can write internal energy change is zero. The reason is internal energy of a gas, there are two types. One is kinetic energy, other one is potential energy. This is we are talking for an ideal gas system. For ideal gas system, potential energy is nil. No attractive force. No. Therefore, its internal energy depends on kinetic energy only. Internal energy depends on kinetic energy. But we know energy, the kinetic energy is directly proportional to absolute temperature. Chemistry also we study, physics also further we will study in ideal gas equation section. Then I am combining these two. Then I am writing internal energy is directly proportional to absolute temperature. Okay. Now then what I am telling is we have the ideal gas equation PV is equal to nRT. So R is always constant, universal gas constant. And this is for a particular gas. Therefore, number of moles won't change. Therefore, we can write PV is directly proportional to temperature. But we already know internal energy is directly proportional to temperature. Therefore, we can write down the relationship like this. PV product is directly proportional to absolute temperature. Temperature is directly proportional to internal energy. So, instead of internal energy, I can write the PV product. Now here, initially it is at A. Therefore, its internal energy is P into, we can say what? Again, finally also it is coming at A. From first it is going from A to B, then going from B to C, then it is going from C to A. Again it is coming to A. Therefore, again its internal energy is U. Therefore, if I calculate the change in internal energy, it is U minus U 0. Therefore, for a cyclic process, the change in internal energy is 0. Therefore, U is 0. Then delta W we calculated plus 3 joules. Then we can substitute that plus 3 joules. Therefore, delta Q is equivalent to 3 joules. Delta Q also we have. If delta Q is plus means what? Heat is absorbed. If delta Q is plus, heat absorbed by the system. That day we initialize. Heat absorbed by the system. If delta Q is minus means heat liberated by the system. If delta Q is minus means heat is liberated by the system. It is going up. Here delta Q it is plus no. Therefore heat is absorbed by the system. Now in this question there are 5 answers. Okay. So already we know it is 3 joules. So from that we can cut off answer 1. Answer 3, answer 4, answer 5 we can cut it off. By answer 3, answer 4 it is telling 6 joules. Answer 5 they are telling no heat is absorbed. Definitely we can't tell no heat, no definitely there is a work. Then there will be a delta. So first answer or second answer. 3 joules. But answer comes delta Q as plus. If delta Q is plus means what? Heat absorbed by the system. Therefore, we can go to the first answer. 3 joule of heat is absorbed by the system. Are you okay with this?
Yeah. Yeah. Okay, teacher.
Okay, write down this and let me.
Yeah, teacher, I'm not doing chemistry. That you said PV is equal to NRG. Is that coming for physics also? That equation.
Yeah, it is coming for physics. You are ICT student.
Yeah, teacher.
Oh, okay. So what is this? Is PV is equivalent to nRT. This we call an ideal gas equation. It is also in physics. We will study under separate section. This we call as ideal gas equation. Okay, then I'll explain it. Now, gases, normally we talk like gases means nitrogen, oxygen. So those gas molecules, if they are separated apart also, there's a small attraction. Now, ideal means ideal student, perfect student, like that we tell. So ideal gas means what? Means no attraction like that. If gas molecules come here also, they will not come and attract. They will always try to be far apart from each other. That we call as ideal gas. So for an ideal gas, there is an equation we will derive. Okay, there are some laws. Boyle's law, Charles' law, pressure law, like that. After that, combine and we will derive. So what are these means? This is pressure. So this is a famous ideal gas equation. This is pressure. This we call volume. N we call number of moles. R we call as a universal gas constant. Universal gas constant. And T we call as the absolute temperature. Okay, we will study under detail. Now you know what are the terms. Okay. So what I have done here is, how did I get this relationship is, yes, PV is equal to nRT. So in this equation, P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant, T is the absolute temperature. A temperature we can measure in 2 units. One is in degrees Celsius and other one is in Kelvin. Absolute temperature means temperature is measured in Kelvin. That we call as absolute temperature. Now the thing is, now how did I get to this relationship? Now this equation is new for you. PV is equal to nRT. Now in physics, for shortcuts and all MCQs, what we do is we cut off the constants. Now R we call as universal gas constant. Okay, that R value is, you would have seen papers 8.314 like that. It is always a constant. That's why I cut it off. N, why did I cut off N is, now this is for a particular gas. Now a gas is only going from A to B, B to C, C to A. So in any process, if I consider, number of moles won't change. That's why I cut off that. Then I took a relationship. PV is directly proportional to temperature. P into V means pressure into volume product is directly proportional to absolute temperature. Okay. Then here what I have written is internal energy. There are 2 types. That is kinetic energy, potential energy. Then for ideal gas molecules, attraction is same. Now potential energy means what? Now if there is plus and plus, it will require plus and minus, it is attracting. So that potential energy is for ideal gas molecules, it is zero. Okay. Okay, that's why I told internal energy only depends on kinetic energy. But again, we will study in physics under the ideal gas law. This kinetic energy is directly proportional to absolute temperature. This is we will study. In chemistry also it is there. In the fourth lesson, physics also we will study under further here. This equation and this equation. That's why I'm combining these two equations and I wrote internal energy is directly proportional to absolute temperature. Okay. Then here see internal energy is directly proportional to absolute temperature. Absolute temperature is directly proportional to PV product. Now initially it is at A. Again it is coming at A. So initially the internal energy is U means now also internal energy is U. Because internal energy depends on the PV product. PV product didn't change. Here PV again it is coming to a PV. Yeah, the internal energy change is 0. U minus U is 0. Then we already calculated delta W as 3 joules. That will be equal to delta Q. Since delta Q is coming as plus, it is heat absorbed by the system.
Yeah.
Now clear?
Yeah, teacher.